So welcome to Pre-Calculus. So my name is Professor Jeremiah Dyke. I'll be your professor throughout this semester. I wanted to take a couple minutes and just mention a few things before we get started with the lecture. So the goal up front is, I guess I'll introduce myself, but I also want to give you some resources, some locations of to find some resources, as well as I want to give you a roadmap of kind of where do you go from here, from your math class that you're in now to the next math class and so forth. So, I guess since you're going to be hearing my voice for the next 12 weeks, 14 weeks, whatever class that you're in of mine, I guess I should take a second to tell you a little bit about myself. So, again, my name is Jeremiah Dyke. I'm a full-time professor at the Fauquier campus. In addition to teaching mathematics full-time, I own a business. I also own a computer and electronic recycling company. Our warehouse is in Winchester. And I have a wife and 2 boys and a dog. I play some video games. My sincere apologies. I'm really not that exciting. I do play some Fortnite. Maybe we'll play together. But not necessarily my apologies to all of you. I'm just not that exciting to talk about. So next thing I wanted to show you is when I'm going through these lectures, I can save you some time because a lot of the problems and the handouts that I'll be using in the lectures, you can download and print them from my website. So I'll go to that right now. So it's just my first name, last name.com, jeremiahdyke.com. Let me do that now. So from here, if you click on courses and you select which course you're in, let's say you're in PreCalc Part 1, what you'll find is just the handouts that, the majority at least, of the handouts that I'll be using in the lectures. It might be slightly different just because there's different versions of the textbooks, etc., but at least gives you something to have access to. All right. So with that in mind, let me go back. Let me now kind of give you a roadmap. So this is important. So I don't know you. If you want to reach out to me and tell me, what you're planning on majoring in, I might be able to give you a little bit better advice. But since I don't know what you are going to do, what you plan to study, let me try to give you just a general roadmap. So typically the way it works is right now let's say you're in PreCalc Part 1. And it's possible there is a what's called Math 167, which is a combination of PreCalc 1, PreCalc 2, all in the same semester. But let's just assume for our purposes that you're in PreCalc Part 1. Now, so let's fast forward. You pass the class. Where do you go from here? Well, depending on your major, you can, if you want, go directly from PreCalc 1 into what we call applied calculus. Now, you would always want to double check with the institution that you plan on transferring to, let's say, to make sure that applied calculus meets the requirements that for the calculus sequence. But normally the types of majors that go into applied calculus would be, say, a business major or marketing, things like this. Now, if you were to tell me that you're in some type of STEM major, right, science, technology, engineering, maybe even mathematics, then you probably have a different route. So at that point, for our purposes, if you don't mind, let's just say you told me you were planning on doing engineering, okay? Well, after PreCalc 1, you would take the second part, PreCalc Part 2. In PreCalc 2, you would learn the trigonometry and, as well as some other vital pieces of information that you would need to do the next class, which would be what we call calculus with analytic geometry. So after you would pass PreCalc Part 2, you would move into Calculus 1, and this is what we call calculus with analytic geometry. To make sure you understand the difference, Calc with Analytic Geometry is a much harder calculus course than applied calculus. And that's why you typically need that a second course of pre-calculus to do it. But if you do plan on doing, say, computer science or engineering, I'm more than likely this is the type of calculus that they're going to want you to take. And finally, let's just pick up the pace here. Again, if you're doing engineering, after Calc 1, you go to Calc 2. And what I tell my students is at the same time you're taking Calculus 2, you should also be taking the class, it's called linear algebra. But don't let the name fool you. It's more like matrix algebra. But you would want to take, if you're an engineering major, you would want to take these two courses at the same time. We normally offer them at the same time. And then after you're done with that semester, you go to Calc 3, and then you go to differential equations. And at that point, if you're an engineering major, you have satisfied all of your math requirements for basically any institution in the state of Virginia. In other words, if you go to Virginia Tech, you would still take, engineering classes. You would still have math in your engineering classes, but you wouldn't have to take any more math classes. Once you've taken differential equations, you've satisfied all of your math classes. And the good news is here at our college, at Lord Fairfax Community College, we offer all of them. Now, the good news or bad news is hopefully you like me. Hopefully you like me and I like you, because I'm all you have. I'm the only one that teaches all of these, all the way up through differential equations, at least on the Fauquier campus. So, nevertheless, we haven't yet determined if you like me. I haven't yet determined if I like you, to be honest. But nevertheless, let's find out. We'll get into the lecture right now. So hopefully that helps, that little roadmap. I hate to see students not know where to go from where they are. Okay, so let's actually jump into this PreCalc 1 lectures. And the way this is going to work is we're going to be learning the pre-calculus that you need in order to do calculus, right? So it's going to be, the way you can think about pre-calculus, it's going to be a combination of algebra and geometry. And what the goal is to pick the most important parts out of those courses, as well as, and refine those ideas, and then you have all the material at that point you need to be able to do calculus. And the way it's going to look is you're going to see a lot of old. In other words, you're going to, like when I start today, you might be bored out of your mind thinking, oh my gosh, I remember this, I already know this. But that's good. That's actually a really good sign that you already know, you can anticipate what I'm going to say. But then we'll kind of move fast, and then we'll slow down, because you'll start to see new topics introduced now and again. But nevertheless, whether you know this stuff or not, it is good just to sit back, relax, grab a cup of coffee, and let's try to reach a higher level of understanding, right? Ready? Let's go. So the way we're gonna, the beautiful thing about pre-calculus is what we do is we take all of those beautiful equations that we were learning in algebra class, and then we take all of those beautiful graphs and figures that we were learning in geometry class, but we actually forced them, right? We bound them into a coordinate axis. So the beautiful thing about using this rectangular coordinate system is we now actually have a way of, let's say if I were to draw a circle. Now, once I impose a coordinate axis, I now have an ability to find the equation, right? There's actually an equation for this particular circle. And that's the nice part. So let's start, but let's just make sure we understand this rectangular coordinate system. Very, very simple. I'll try to move fast, but not too fast. So what you can imagine, is we have two lines, right? So does it make sense to you? Let me slow for just a second. Does it make sense to you that every number that you've ever encountered, probably, or at least that you use on a daily basis, every number is going to be located somewhere on this line, right? It goes from negative infinity to positive infinity. I mean, the number 3 is on there, the number pi is on there. Every number is somewhere on this line. Likewise, same idea. We have another line, and that's also made up of all the real numbers. But when the way the rectangular coordinate system works is we take two lines and have them intersect at this 90-degree angle. And then we can start to think about, instead of thinking about one-dimensional numbers, or let me not phrase it that way. Instead of thinking about life in one dimension, right, where everything is located on a line, we can now start to think about life in 2 dimensions. And that's where this journey begins. So let me see if I can make sense of this for you, right? So take point A. Let's say that, I don't know, point A, you're at point A and you're trying to give me directions to get to you, right? There's a party going on at this location. You're trying to help me out with directions. Now, if you'd like, let's think about all of these lines as roads. So I think it would make sense to you that you're going to have to give me both a longitude and a latitude in order to get to you, right? Right? You can't just say, yeah, just go right. And, I'm never going to get to you if I continue to go east. No, I'm going to have to go east, and I'm going to have to go north, right? You would have to give me the longitude and the latitude of where you are. So the way the analog to that, the way we think about this point A, is it has a horizontal distance and it has a vertical distance, right? So the horizontal distance is what we refer to as x. And then the vertical distance is what we refer to as y. So although you don't see it, at least I don't think I can spot it here, what you have this vertical line is what we refer to as y, and this horizontal line is what we refer to as x. All right, so this point A, what we've discussed is this point A has 2 components. It has both an x component as well as a y component. And now, mathematicians love to give things names. That x component is what we refer to as the x coordinate. That y component is what we refer to as the y coordinate. But once you have both, what you have is what we call an ordered pair, right? So an ordered pair. So what we're going to do right now is we're going to start off very simply. We're just going to, I'm going to take point A, point B, point C, and we're just going to find the ordered pairs of each. Ready? So let's just go ahead and go through this quickly. So let's start with point A. All right, so with me, the goal is what's the x component, what's the y component? Well, where do we start? Well, we always start at the what we refer to as the origin, right here in the middle, the intersection of these the y and x line. And the only thing that we need to do is we need to decide, do we always, in other words, let's you and I decide right now, do we always go left to right first and then go up and down? Or do we go up and down first and then left to right? Well, the way we have decided in this science is that we'll always start left to right. All right, so you'll start with your x position. Ready? So let's go ahead and start. So I'm going to be moving. My eyesight's not that great, but that should be 3. All right, so I'm going to move 3 to the right. So 3. All right, so now that I'm here, I'm going to be going in the y direction. It's either up or down. In this particular case, we're going up. And what is that? 5. So at 3, 5 is the location of A. Let's do B. All right, let's pick up the pace a little bit. So now we're going to be started off. We're going in the negative x direction. So we're going to go first. We'll go all the way to -6. And now that we're at -6, we're going to start moving in the positive y direction, and we're going to go, I believe that's 2. One more, and we'll be. I won't keep you here. We'll do one more. We won't do part D. All right. So now we're trying to get to point C. And let's get back to the origin, back to the starting point. All right. Again, we always go left to right first. So let's go. We need to go in the negative x direction. Right. We need to go -2 in the x direction. All right, and then once we're here, we're gonna be moving in the negative y direction. So we're going down, and I believe that's -3. All right, so unless my eyesight is, betraying me, I think we're good to go. Let's move on to well, actually, before we move to the next topic, let me just state something really quickly. So does it make sense to you that any point in this quadrant right here, you would be in the positive x territory and the positive y territory, right? Does that make sense to you? You would have to go positive x direction and positive y direction. So what you're seeing at the top here is we label these quadrants, and that plus just means that the x is going to always be a positive number, and the y is always going to be a positive number. Quadrant 2 is you're going to be a negative. Every point over here will have a negative x and a positive y. Now, once you get to quadrant 3, every point in quadrant 3 is going to be in the negative territory, negative x and negative y, and that's exactly what you saw here, -2, -3. All right, let's now move to the next topic. So we want to study equations in 2 variables, or even more than 2 variables. And now what I want to do is I want to try to talk to you about, what does it mean to say something is a solution, or to say something is equal. So the highest form of equality in mathematics is what we refer to as an identity. So, for example, x plus 3 equals x plus 3. Now, that equation is always true, no matter what you pick for x. Agreed? If you pick 0, it's true. If you pick 1, x is 1, it's true, no matter what you choose. This is what we would refer to as an identity. it's a higher form of equality because it's unconditionally equal. Now, that's not true for an equation like this. So in this particular equation, y is equal to 4 minus x squared. Let's slow down. We have two variables, right? We have two unknowns. We don't know x, nor do we know y. But we do have a relationship. We know that y, I can get the y variable if I just take 4 minus the x variable squared. All right, so this is what we call a conditional equality. It's a lower form of equality. It's a conditional equality because you'll see in just a second, and I'll come back to that point. So now let's take the concept of the ordered pair and the concept of an equation in two variables, and let's see how these guys relate to each other. So let's see what happens if I substitute a 3 in for the x, and I substitute a -5 in for the y. Ready? So let's just see what happens if I do this. All right, so bear with me here. So again, all I'm doing is just substituting. So let me go ahead and substitute. I'll draw you a quick picture. So I'm going to be substituting the -5 in for the y. Let's start there. So that's -5 equals 4 minus, and now I want to substitute this 3 in for the x. And if you don't mind, let me show you something that will save you from making a lot of really silly mistakes. Let me show you a little technique. So I've been doing math a long time, right? I've spent a long time in school studying mathematics. But if you were to ask me, even to this day, to plug in for x, the first thing I'm going to do is I'm going to put some parentheses here. So now notice that instead of having x squared, I have some open parentheses squared. And therefore, we can just think of it as dragging and dropping. We're going to just drop this 3 right inside these parentheses. Now, and let me finish this, and I'll show you why that little technique of the open parentheses can save you a lot of trouble. Ready? So let's go ahead and evaluate the right side of this equation. So we have -5 equals. All right. Well, you know what to do from here. It's just 4 minus. Well, we got 3 squared. Well, 3 squared is 9. So that, in other words, we have -5 is equal to 4 minus 9 is also -5. Interesting. So when we plugged this point, this ordered pair, into this equation, do you agree with me we got a true statement? Now, what if you were to plug, let's plug in another point. Let's make it really easy. Let's say 0, 0. Now I'm going to do this quick, but I want to so if I plugged 0 in for x and I plug 0 in for y, well, that would be 0 is equal to -0. Oh, I'm so sorry. I forgot my 4, didn't I? So let me try that again. 0 is equal to 4 minus what? Minus 0 squared. In other words, 0 is equal to 4. Well, this is not a true statement, right? I mean, the law of identity tells us that A has to equal A, right? So 0, we can't live in a world where 0 is equal to 4. Now, what does that mean? So here's a point. When we plug it in, we get a false statement. Here's a point that when we plug it in, we get a true statement. Well, what that means is we would say that this first point, let's go back to this first point. This first point, the wording, the terminology is satisfies the equation. Whereas the second point does not satisfy the equation. In other words, if you're still with me, right? You still with me? You got your cell phone in your hand, 2 or 3 tabs open in your computer. You got a controller in your hand, right? Maybe playing a video game while you're listening. It's okay. It's all right. All I'm trying to state is because this point satisfies this equation, then what we would expect is that when you graph this, if you were to graph this out, and we'll do that in just a second, if you graph out this equation, somewhere on that graph, we would find this point. That graph goes through that point 3, -5, okay? Now, let me. I made a statement. I have to be careful. So I made a statement about why do I use these parentheses. So, forgive me. Let me erase some things. I'm going to give myself a little bit of space here. And let me now get back to the statement that I was making. So let's assume that I give you the equation y equals x squared, right? And then I tell you x is equal to 3, and then the second part is x is equal to -3. If you have a calculator, anywhere around you, try this. Try taking 3 squared on your calculator and try taking -3 squared on your calculator without parentheses, right? I didn't use any parentheses here. I didn't use any parentheses here. So let's actually answer the question, and then let's make sure you understand why the use of the treatment of the parentheses is important. So when you plug in 3 for x and then square it, well, 3 times 3 is what? It's 9. When you plug in -3 and square it, well, -3 times -3 is also a positive 9. But if you try this right now on your calculator, y equals -3, then squared, and you don't use these parentheses, here's what your calculator is going to say, -9. You don't believe me? I'll prove it to you, right? Maybe you're like, I don't have a calculator, Professor. I don't have a calculator in front of me. That's okay. Ready? Watch. So -3 squared. See how I did not use parentheses? And I got -3 squared is -9. But wait a minute. We just got done seeing that -3 squared is not -9. It's positive 9. So that's why we use these parentheses. Because your calculator, when you put this in your calculator, the calculator thinks you want to do 3 times 3, and then whatever that is, multiply it by -1. So your calculator doesn't understand that that really what you meant was this. There's a difference. All right, no more discussing it. So the last little thing that I'd mentioned that I wanted to come back to was the idea of, I had mentioned a conditional equality versus a unconditional equality, right? Remember me saying that there's the highest form of equality in mathematics is to say you are identical. And then a lower form of equality in mathematics is a statement like this. So let me get rid of everything, because the only thing I need is this part to make my point. So when you plug in 3 for x, you get out 9. That is a conditional equality, meaning it is equal under the one condition that x is 3. You have to meet that condition before you can say it's equal. All right. I want to move to the next topic, and I want to try to go through this quickly. So if you want to plot points, right, and if just imagine, so we have this y equals 4 minus x squared. And let's pretend for a second, I realize that this equation really means nothing to you, it means nothing to me. But let's you and I assume for just a second that whatever it is that we're doing, this equation has meaning, right? I don't know what we're looking at, I don't know what we're trying to model, but whatever it is, this means something to you, this means something to me, okay? Well, so we have an equation. If you want to look at the geometry of this equation, how do we do that? How do we get to a graph from an equation? All right. Well, let me show you. The more tedious way of doing it, the longer way of doing it. I'll go through it quickly, and then I will show you how we can use technology to do the same thing. All right. So if you were taking this class, say, I don't know, 50 years ago, right, 60 years ago, pre-calculator revolution, well, if you wanted to graph an equation like this, you would be plotting points and connecting dots. Okay, well, how many points do you need? Good question. We're not going to spend all day here, so let's just pick the following points. So let's say -2 for x, -1, 0, 1, 2, 3. All right. What did I just do? Well, don't you agree with me? If I want to draw a graph, I need dots, right? I need points, and then I need to connect my dots. Well, so the first thing to do is to find some points. Well, how do I do that? Well, so since this equation is solved for y, let's just pick some arbitrary x values. This actually, for some students, especially if you haven't been in math class a while, this confuses students, because they'll think, well, why did he pick -2? Why didn't he pick -3? Well, I could have, right? I could have picked, negative, 1/3. I could have picked anything, but I just want to pick some numbers that are easy to work with. Okay, so that's why I chose the ones that I chose. All right, so where did that -2, -1, 0, 1, 2, 3, where did it come from? Well, it just came from out of the air. I just picked some random values. But now, once I have said that x is -2, this y value is not arbitrary, right? I don't know what it is yet. We'll figure it out in just a second. But I need to take -2 and plug it in for x. And then that is what's going to tell me what y would be. Ready? We won't do all of these. Let's just do the first few. So in this scenario, I have y equals 4 minus, right here, there's those open parentheses. And ready? Let's go. Let's take -2 and drop it in here for x. All right. So nothing left to do except, just evaluate the right side. So that's going to be 4 minus, well, negative 2 squared is negative 2 times negative 2, right? So that's going to be 4. So we end up with 4 minus 4. In other words, y is equal to 0. All right, so stay with me. Stay with me. So I'm going to now take this 0 and put it right here for y. So 0. So when x is negative 2, y is 0. Okay, so to speed up the process, I'm going to do the same thing that I did here for the rest of these. I'm going to plug in a negative 1, plug in a 0, plug in a 1, and so forth. And let me go ahead and just fill in these answers. So if I plug a negative 1, I should get a positive 3. If I plug in a 0, I get a 4. If I plug in a positive 1, I get a positive 3. If I plug in a positive 2, I get a 0. And if I plug in a positive 3, I get a negative 5. All right. So let me go ahead and erase this little work right here. And let's finish this problem. Ready? So I have produced some points. This is what we call it. Just it's normally called a table method for plotting points. So I have, of course, assuming that I haven't made any silly mistakes, I have 5 points that I want to plot. And then I'm going to try to connect the dots. Are you ready? This is probably a bad call in my part because I can't read that very well, but let me see if I can do my best. So negative 2, 0. Negative 1, positive 3. 0, positive 4. Positive 1, positive 3. Positive 2, 0. And that last one is positive 3, and that's negative 5. So down here. Okay. Now, I agree with you that that we only have 5 points, right? So a student could argue, wait a minute, how do we know how to connect the dots, right? I mean, how do we, like, because I'm going to draw a parabola like this when I connect them. But I can see a student saying, wait a minute, professor, how do we know? How do we know it doesn't go like this? Right? Or something, like, or zigzag. How do we know? Well, it is true. It is true that you, just from this information, you don't know. There is some things that you could infer, but let's be honest. If you wanted a better graph, then you would need what? You would need more of these points. And that's actually exactly what your calculator is doing. When you use a calculator to graph, when you use your calculator to graph an equation, you know what it's doing? It's just going to create a whole, like 1,000 of these little ticks, and it's going to connect them. That's it. That's really what it's doing as well. So the more points you have, the safer you are with your graph. But nevertheless, if you were to try to connect the dots here, it would look something like this. It's hard to draw it by freehand. And this would keep going. And this would keep going. So that's in general what the graph would look like. It's just what we call a parabola. Okay, so if I don't know what type of calculator that you'll be using in this class, if your calculator is one of the Texas Instrument type of calculators, it looks something like this maybe. That's kind of what I'll refer to because they tend to be the most popular. But listen, if you have something else, it's okay. It's no worries. And if you don't have to rush out and drop $100 on a calculator, unless you have the money, you can buy these calculators used. In fact, if you shoot me an email, actually I don't know how we would meet, but because I give away calculators whenever I told you I own a recycling company. Whenever someone gives their old calculators, into me to recycle, I try to give them to students when I have them. But nevertheless, you can always buy them used on Amazon or eBay, and save some money. But nevertheless, here's what I want you to know. If you wanted to graph this on a calculator, you would hit y equals. I'm trying to highlight it for you right here. Once you hit y equals, I'm going to go button by button, okay? So the equation is 4y equals 4 minus x squared. Ready? Let's go button by button. So you would first hit y equals. Then the next thing you would hit is 4 minus x. Now what is x? Well, these buttons right here are your variable buttons. So you would hit if you hit this button, as long as you're in the right mode, you'll see the x. And then it's going to be x squared, so you would use this button right here to square it. All right, so 4 minus x squared. All right, that's the order. At that point, after you just hit this button to graph it, and then your display would look something like this. Here in just a second, I'm going to show you a free graphing utility, and you should use it. I mean, it's a beautiful graphing utility. You can even put it on your phone. So you don't even have to purchase one of these expensive calculators. I'm going to show you just a second. A beautiful graphing utility. But all right, so once you graph it, you can see that it's fairly similar to what we have above. And then another thing that you can do, all right, my apologies, you probably can't see this very well. This is called a table. If entertain yourself for just a second, I'm going to try to make that larger. So this is an interesting feature. You might not even, maybe no one ever showed you how to do this on your calculator. But let me show you really quickly. So after you did y equals 4 minus x squared, instead of hitting graph, try this. Try hitting the second button and then the graph button. Right? So when you hit the second button, you're going to now use the secondary feature, which is table. And once you hit second graph, this table pops up. And look what's on this table. You have a whole bunch of points. Right? I mean, you have all of these are points on the graphs. Right? Can you see some of the ones we did? -2, 0, -1, 3, right? So that's a feature. Let me show you a really, really good utility for graphing. So the website is called Desmos, Desmos. It's free. It has there's the apps. You can put apps on your phone or tablet that's free, and from here I can just also do y equals 4 minus x squared, and you could graph it that way, and it's nice. I mean, you can then pick, you can see information about the graph. Okay, I think at this point you've heard me ramble for quite a bit, so let's go ahead and take a break, and we'll come back for part B of this video. See you there.